Hello there, you are welcome to New Focused Approach to Mathematics Basics 7, and this is the revised edition. In this video, we want to look at powers of numbers, how we can express given numbers in indices form. Powers of numbers simply means you're looking at indices or exponentiation. Indices or exponentiation. For example, if I have a number 2 times 2 times 2 times 2, can I write this in a very simple way? And I can just say 2 is multiplying itself 4 times, so I can write it this way. If I have 3 times 3, can I write this in a very simple way? I can say 3 and it's multiplying itself 2 times. What about if I have x times x times x times x again times x again? It's quite long, right? But then how can I write this in a very simple way? I have how many x multiplying itself? 1, 2, 3, 4, 5. So I can say x is multiplying itself 5 times. Anytime you write product or multiplication of numbers by themselves in the form of this, then we call this indices. This is the index form of the number. With these indices, the number here, the 2 that is multiplying itself, is called the base. It's called the base. And then the 4 telling us how many times the 2 is multiplying itself is called the exponent. Exponent. Okay, or index. Index. Okay, and the plural form of index is what we refer to as indices. Indices. And so here the 3 becomes the base, the x here becomes the base. The 2 here is called exponent, the 5 here also is called exponent or index. Now, our major target here is to learn how we can write a particular number in an index form or indices form. Let's take, for example, 64. We want to write 64 in an indices form. So the question is, we search for a number that when we multiply it by itself number of times, we'll get a 64. So I can look at the least number I can use. If I use 1, actually 1 times, no matter the number of times we do, will always give you 1. Okay, so 1 times 1 times 1 will give you 1. So 1 wouldn't be an ideal one to use, but I can try 2. Then 2 times what? I know 2 times 2 will give me 4 times 2 will give me 8 times 2 will give me 16 times 2 will give me 30. 2 times 2 will give me 64. So I can see to the power 6, or I can say 2 exponent 6. That means 2 times 2, 6 times will give me 64. Again, if I pick 49, I know I'm going to do, I can't use 3, I can't use 4. The reason is that 3 cannot divide 39. So there's no way if I repeatedly multiply 3, I can get 49. But then I can think of 7, because I know 7 times 7 will give me 49. So 7 exponent 2. When I pick 27, 2 cannot divide, so I wouldn't choose 2. 3, okay, 3, because I know 3 multiples of 3, we can get 27. But I can still say 3 times 3 times 3 will give me 27, because 3 times 3 is 9, 9 times 3 is 27. So this becomes 3 exponent 3. Then here, again, I can't use 2 because 2 is not divisible, because the last number is odd. 3, yes, I can think of 3, because I know 3 times 3 times 3, 3 times, okay, that gave us 27, right? And then again, if I go times 3, okay, I'm going to get 81. Then times 3 again will give me 248, 243. So I can say 3 exponent 5 will give me 243. Finally, I have 125. When it ends with 5, I know I'm dealing with either 5. And 5 will be the easy way out. So 5 times 5, I know it's 25. Times 5 again, then I can think of 125. So 5 exponent 3 will give us 125. That means 5 times 5 times 5, and that will be 25 times 5, and that will give you 125. All right, the last thing we want to talk about is determining that any natural number with exponent of 0 is always giving us 1, or any non-zero number raised to the power of 0 is 1. How do we prove this? That is what we want to do as the last thing. We want to start with 2 exponent 5. We know 2 exponent 5 will give us 32. That means 2 times 2 times 2 times 2 5 times will give us 32. If we reduce the exponent by 1 and we come to 4, then that is going to give us 16. If we reduce the exponent by 1 again, I get to 2 to the power 3, I have 8. Now let's observe a pattern here. We are reducing the exponent by 1, by 1, by 1. Let's see what happens to the result. 2 to the power exponent 5 is 32. When I reduce it by 1 to 2 exponent 4, I divide 32 by the base 2, I get 16. Then when I reduce it to 3, I divide 16 by the base 2, I get 8. If I reduce it to 2, I divide 2 here and I get 4. If I reduce it to 2 to the power 1, I divide again here by 2 and I get 2. So you can see that 2 exponent 1 is 2. When I reduce it again to 2, from 1, I'll go to 0. Then I will divide here by 2 again, and that will give me 1. If I go again, I go to -1, then this will be divided by 2, and I'll get this, which means 2 exponent -1 is the same as half. Okay, so realize that when we go to 2 exponent 0, the answer gave us 1 here. Now, what will happen if I try with a different number? Let's say I try with 5. Rather, I try with 3. I know if I have 3 exponent 5, that should give me, we did that earlier, so that gave us 2, sorry. That gave us 2, 4, 3, right? Then when I reduce this one to power 4, exponent 4, it means we divide here by 3, right? And that when we do, we get 81. If I reduce this to 3 exponent 3, we divide here by 3, and that will give us 27. If I go to 3 exponent 2, I divide here by 3, and that will give us 9. Again, if I come to 3 exponent 1, and I divide here by 3, I get 3. Once again, 3 exponent 1 gave us 3. If I reduce it to 0, and I divide here by 3, I get 1. If I move from 0 to -1, I divide here by 3, I get 1/3. So you see what is happening. If you continue this with any number and you reach a stage of this sort, you always get 1. So if you use 5, 6, 7, 8, and you come down step by step, you always land to 1, which means any number, any non-zero number raised to the power 0 will always give us 1. Will always give us 1. And that is the proof. Right. With this, we come to the end of this video, learning how to change a number to an index form. Stay blessed.